Alright, a video response of sorts to some points raised by Hothliday. So, in the first, 10 minutes or so, I'll jump ahead because I don't need to play this part. He was a sort of saying that, yes, I'm right to raise these objections about the wave equation, but he didn't really explain how I'm right. So, the point is Maxwell's equations, especially as Maxwell illustrated the force, it can be understood as essentially a radial force, and it has positions in space, either r plus or minus, and they're to a certain amplitude. And you could do that with every point in space. And there's no need to do sine waves or anything, because it really just has to do with what kind of energy is traveling through a location. And so in the equations, the only thing that really matters is stuff at a frequency. So you could understand the equations any way you want to, in terms of just recognizing that the basic equation is just saying there's a bit of energy traveling at a certain speed in a certain direction. So if you want to, I guess I have to put the drawing thing on for you to see it. Good idea, Gary. So if you want to, you can sit there and say, okay, it's a wave, all right? And you can think of the wave as having some sort of midpoint. But the only thing that's going to matter in the end, okay, in the real formalization of the effect, is the distance between this and this. That's the amplitude. That's the substance. So you could think of the wave as just this clump of stuff at a distance, at a frequency, at a wavelength, a lambda. Okay? And it's the same thing. Because if you think about what the wave is, okay, especially the sine wave as traditionally drawn, not too traditional there, all of this stuff and this stuff obviously just cancel out in a sense. So it's all superfluous, because this wipes out this wipes out this, because they're opposites. So it just wipes everything out. And all you really care about is this amplitude difference, this distance difference. And that's all there really is of the wave. So, but there's nothing in the math that demands any of this. The math really is just saying there's quanta. They should understand that, right? It's quantum mechanics. There's quanta at a distance. That's what the math is doing. And it uses a sine theta. There's no, there's no wave functions. There's no wave equation. There's an angle equation. Sine theta is an angle. Right? It's not a wave. It's an angle. And there's an amplitude at that angle. There's an amount of force moving that vector. It's vector math. Okay, so enough of that. We'll definitely be back to the drawing table. I hope that'll keep you interested and excited. There's all kinds of interesting things happen over there. All right. Sell it, Gary. All right, so let's move ahead in his video to somewhere around 10 minutes-ish, where he starts to talk about the experiment and gets it all wrong, of course.
See a tuned circuit, tune the capacitor, tune the inductor, I don't know, can't remember. And I've seen some recent circuits where they're doing it with the parallel resonance. Here I'm showing a series resonance circuit, and it wouldn't be, when I say it wouldn't be terribly hard, it means I could probably, I'm confident I'd be able to do it in
Okay, so that worked. Let's see if I can get this.
6 months.
Yeah, okay, I got the space bar working. So I would rather see what I'm producing rather than his video, because I've already seen the video. All right, so the first thing he's arguing, and people do this. I mean, it's okay. I mean, they haven't seen everything I've seen, so they don't really understand this. All right, so I have pointed out a couple of times, though, that Professor Lewin does an experiment. All right, where he has a regular radio transmitter in the megahertz range, AM range, and he's got two antennas, and he takes another antenna, all right, and moves it through the room, okay, picking up the signal from this antenna, all right, and he has a little light bulb on it. That's it. So he's picking up the electricity. So he's obviously producing probably 100 watts into the transmitter, a pretty good signal, and he's receiving it, with an antenna 10 feet, 20 feet away. And the little light bulb lights up when he has the right polarization. So if he takes it out of polarization, it goes off, and if he has the tangential polarization, it lights up. I think it's tangential. Yeah. Are they lined up? No, I think it's tangential actually. Just don't remember. Sorry. It's probably an important detail, but I just don't remember. It's tangential usually. See, the force comes out here around this comes out in planes. So if you thought of this and just say little planes of energy are coming out. So if I took a paper circle, piece of paper, and I made a bunch of little pieces of paper around this antenna, that's how the energy is coming out. It's coming out sideways, out of the side of the antenna in that plane. It's not coming out this way. It's coming out this way. So it looks this way, but it's coming out this way. People don't really understand that. So when you receive it, you have to be tangential to it because you want to pick up the energy going this way. Because the energy going this way, there isn't any. There's lots of energy going this way, not too much energy going this way. No, that's the wrong way to say it. No, well, anyway, let's just pass on that one for now, as it doesn't get complicated. Because I think the radar ones are actually opposite. But anyway, it always comes out this way, all right, from the transmitter. And the idea is just to have the right alignment to get the most of the light, so to speak. You get more light if you're this way than if you're this way. All right, anyway, more photons. You'll collect more. A lot more. All right, because the R part is going only in one direction. It's only spreading this way. There's no R going the other way. Yeah. The antenna really is like that. It's really only spreading this way. It doesn't spread much this way. So like when an antenna is on top of the Empire State Building, the force coming off of it is spreading this way, horizontally. It's not spreading this way much at all. I mean, it does some, like a laser beam spreads a little, but it really doesn't spread much this way. It spreads a lot this way. Okay. See, these are all important points, and getting them all in order is not a simple task. Getting each one of these little points correct, not simple. All right. So the point is that okay. So I've seen Professor Lewin do it with a light bulb. He's just picking up the energy off the antenna. So he has like 100 watts. So you think about it like it was actually a light bulb, and you think, oh yeah, 100-watt light bulb. I could probably detect that from 40 feet away with a sensor. Easy. 100 watts, pretty good light. So the antenna is putting off enough energy that if you have a very low voltage light bulb, you can get a little light out of it. So he turns the lights off because it's a little tiny bit of light, but he's doing it. All right, then there's another one that just makes all this obvious. There's a video on YouTube somewhere where there's an AM transmitter, and about a half mile away they strung a bunch of wires for high voltage, but they hadn't been connected yet. So maybe it's a half mile of wire. So the half mile of wire is collecting the radio signal, and it's creating a voltage in the high tension wires. And so when the electric guys were playing around and they connected it to ground, they got a nice little spark. And when the spark was going between the ground and the wire, you could hear the radio station, because that's AM. See, AM is taking the higher frequency and turning it on and off to send the music. And that was exactly what you could hear. You could hear the spark was on and off. The electricity going to the ground was turning on and off at exactly the same speed as the on-off music. And so essentially, when the sparks were going through the atmosphere, they were vibrating the atmosphere, and you could hear the radio station. So no tuner, no crystal, no amplifier, no tune dials, no volume, no power, no nothing. Okay, just a wire shorted to ground, and you could hear the music of the radio station. So I'm just pointing out, there's no theoretical reason why you can't just induce the electric current into the antenna and read the voltage, as long as your transmitter is producing enough watts. Okay, so that's point number one. No, that won't work. I have to be in. See, it's just so annoying. I have to be in Firefox.
To study up on, you know, the electronic circuitry of broadcasting this.
No, sorry, I should have sped this up. So I'll do that now. Uplee's a little slow. I don't mean that in a negative way. It's nice to be methodical and all that kind of crap, but yeah, it's a little too methodical sometimes. But whatever. It's easy to speed it up, not a big deal. No offense meant or intended. Do I have the... No, of course, I still have the drawing on. Okay, jeez. Little details, just a lot of them.
Even make yourself a little kit, blah, blah, blah. But the point here, or the question here is I don't believe in...
You probably shouldn't do a live room. You probably should do a video that uploads, just because the volume's a little better if you do that. So just saying. That's all. Just saying.
And was suggesting it a proper experiment which could be implemented. He'd have to further specify how he would be happy to amplify that signal, that here, and show an output.
All right. So again, I would argue that, you have to understand there's two ways to do the experiment, okay? And you can't mix the two. So let's draw the experiment just so everybody understands what he's talking about. Drawing on. Okay. So the idea is you have this particular. So there's two experiments. One experiment is you just do this two sources, and then you just move a target, and you detect the energy. So this is kind of simple. Okay, the idea is that the waves come through, they hit at different locations, and you get this on-off pattern. I'm arguing you don't need to do this with a tuner. This experiment, if you did it with just a nail and picked up the microwave signal, the microwaves will produce way more than enough voltage in the antenna for you to read when the dishes are on and when they're off. And you'll know exactly how strong the signal should be when they're on and how strong the signal would be when they're off. And you'll detect going across this field, in my opinion, obviously there'll be more current in the middle, okay, and there'll be less as you go further away, but there'll be no on-off pattern in the receiver. All right, so that's one experiment. Now, the one I have proposed is a simple way to further verify that this is just signal jamming. So that one doesn't require you to use a receiver of any kind, except a voltage meter, or as Steve has. He has a very nice older meter that picks up a high range of microwave signals, so he could probably just use that. Well, it's not going to pick up double frequency though, so probably not. Yeah, so no, he couldn't use that. It's still frequency limited, and you need something that's completely unfrequency limited, so you need a voltmeter. And so I think he could do that. Anyway, I think that's infinitely doable. Completely doable with microwaves. You could use it boiling water, as he's going to bring up later, and I'll point out how he's wrong about that also. Anyway, so the new version of the experiment is just put the two guns opposite each other, all right, and then have your receiver somewhere, generally speaking, in between them. And for this experiment, yes, you will have to detect the frequency going to you received by the antenna. If you don't detect it by frequency, you're not gonna be able to tell anything. You know, because you have to use the carrier signal in this case. So the point would be is you just tie this to a receiver that can pick up a high range of frequencies. The carried frequency plus a double of the carried frequency, and yeah, you'll be able to detect that when you move these into positions where the two signals end up out of phase, you'll lose your audio signal, and then when you move one of them a little bit more away, so you change the phase, then you'll hear the signal. And the point will be is it'll just demonstrate that there's no necessity for these two waves to ever interact with each other to get the same on-off pattern. So just moving this way in this experiment, you'll get on, off, on, off, on, off. So you get the same pattern, and the two waves never got anywhere near each other until they were past, right? They're not interfering with each other until they're past the antenna. So quite obviously interference couldn't be blamed. And the only thing that could be blamed is signal jamming. So those are basically the two experiments. I didn't do that perfectly, but anyone who's been following along should have been able to follow along. So next. I mean, he raises a couple of points that I'll get to.
I've just watched the old MIT video that he linked to in one of his videos, and it's a great little old video whereby the criticism that DraftScience makes about noise, sound riding on a carrier signal, and this being a problem, is not the same. I'm not saying it's not arguable. In character it might be the same, but certainly not exactly the same in the fact that in that old MIT video, he says he makes an audible sound because he's broadcasting pure carrier wave, but he's chopping it at an audible frequency. Now, that would require some analysis and argumentation.
No, it wouldn't. I mean, he says from DraftScience. I don't have to explain that at all. It's quite obvious. Again, as I pointed out before, that's the experiment you can do without the receiver. You don't have to amplify the signal. So he had the nail sitting there, basically, sitting in front of two radar dishes. And what he should have just done is measure the voltage on the nail. All right, they had the technology to do that. And if he did that, he'd find that, yes, it doesn't matter what frequency is hitting the nail. The nail only cares about the electricity. So the nail's just going to create a current. The current's going to go up and down. All right, so when there's when the frequencies are in phase and when they're out of phase, it's just not going to care. It's not going to care. The nail's not going to care because it's not frequency dependent. It's not going to care whether the frequency's doing this or the frequency's doing this. It's just not going to care. It's going to get hit by a certain number of photons, a certain amount of wattage is going to be in the nail. And that's what you're attempting to read. It's going to be in the form of voltage and current. It's wattage in the nail. So that's the experiment they should do without the carrier signal.
On the behalf of DraftScience, I would say. So I'm trying to work out this. There's a second here. I'm just terribly worried that the audio's not working. Anyhow, somebody will have to amplify it. Kind of relevant. So, right. So the other thing is about these experimentations, recreating the MIT two-horned microwave interference experiment, minus the sound signal.
So again, it's not a problem. So he's implying that somehow I'm completely dependent on circuitry, and I'm not opposed to circuitry anyway. Nowhere in the videos have I said equipment can't measure frequency correct or can't measure the amplitude of the frequency. I'm not looking for an out here. I've been very clear in what I'm predicting, is I'm very confident I'm right. Okay, photons don't interfere with each other. You can keep pretending they do, but they just don't. You can't make lasers interfere. You can't make light bulbs interfere. You can't make any light interfere ever, okay, without doing something bizarre like shooting the light through refractive surfaces. you know, that's every reason to believe that's what's causing the interference. I'm just saying I'm quite certain I'm correct, and I'm not looking for any way to weasel out. So that's just a bullshit implication that I'm going to make some frickin' excuses. I mean, certainly if the experiment's not done right, it's not done right. But I mean, to sit there and prejudge and say, oh, he's just going to make excuses, it's just kind of a horseshit thing to do, buddy.
No, too. So I thought, oh, the problem is this. The thought, it's okay throwing out a thought experiment, but you need to throw out a bit more details about how you want it experimentally carried out. See, my friend, DraftScience friend, Steve, I'm not sure how you pronounce his surname, but Stephen Brow, is it? Or Brough, or whatever. No.
All right, so again, this implication, somehow, I did the video. It's not that complex an experiment. I'm making more clarifications, okay? So you do the two-horned experiment where the two horns are next to each other, all right? You do that without a receiver, and you do the one where they're opposite each other with a receiver and a carried sound wave. Damn, I hit the wrong button again.
He plans to, there's got equipment to, recreate the MIT experiment.
Okay, now it stopped. Let's see if it works.
With a frequency, and he has a frequency counter for the microwaves. But that frequency counter is working with an amplifier circuit.
Yeah, I know. Well, obviously it can detect any frequency. So the point is you can set it to detect 7 gigahertz, or you can set it to detect 14 gigahertz. So the point is you'll be able to find a signal if it's there, because you can go through the whole range of frequencies. And it's going to help you because it's going to be seeking frequencies for you. So it's like a radio that seeks a radio station. All right, so it's not going to be all that difficult in the sense that, quite obviously, it's going to find frequencies that are above the noise level. That's all that radios do. That's all that anything ever does, is it just finds something above the noise level.
Then a digital readout of frequency through, no doubt, some sort of analog to digital converter.
And again, I've never stated I have any objection to using a converter. My whole point is that you can't, if you're not detecting the carrier, you can't obviously hear what's being carried. So the whole point is if you're tuned to a frequency that the carrier is no longer at because it's interfering, because it's done this, then of course you're not going to hear what's on it because you're not receiving the carrier signal. If you're tuned to 101, and you're creating 202, you're not going to hear 202.
So if he showed, because he's had to modify so his transmitters to make sure that double frequency, single and double frequency, are within the range of his frequency counter. Now, I suspect, and I'm confident that when and if he recreates the experiment, it would confirm classical physics.
Yeah, well, you can be confident. I'm confident. So yeah, the sooner the experiment gets done, the better. I'm sure you're wrong, and you've been wrong before. So it'll be your pattern. So you'll be consistent at least. I don't know why you're investing in it, frankly. I mean, you've seen enough of these videos now. You're kind of familiar with some of these concepts. Do you really think Okay, it was bad enough when they said single photons split in half and interfere with each other. And now they're saying, oh no, independent photons also interfere. That's what they're saying. So theoretically, what they're saying, if I had a lighthouses, right? See, that's what you need. You need gigawatts of light, right? I mean, just like a light bulb, a lighthouse you can see from miles away. Because guess what? It's kilovolts, megavolts, and that's the same thing that's going into radio antennas. So of course you can see them for miles because they're really bright because they're consuming a huge amount of watts. I mean kilowatts. Sorry, I keep see all those little Freudian all that little bullshit. You always have to get this stupid watts, volts, get all this fucking shit right. Hertz. So signals are megawatts. A megawatt radio station. Well, if I had a megawatt lighthouse, and let's say I have a red one over here, and then I put a blue one over there, okay, and I shine them, I'm not going to get green. Or, yeah, red and blue. I'm not going to get violet. The light's not going to mix. The photons will not interfere with each other. They will not do anything. All right. The photons themselves won't, but of course an eyeball will see violet. So I guess I shouldn't use color because obviously our eyes blend colors. I mean they do exactly what I just said. They take blue light and red light and they make violet. So you will see violet. So let me say you put a frequency on it, a carrier. The carriers aren't going to get mixed. How else to put this? Well, the carriers will too. But there's not going to be any interference patterns. The photons aren't going to bang into each other. You know that doesn't happen. So I don't know why you're saying I'm going to invest in this classical nonsense where they're saying photons interact with photons. I mean, by now you should have figured out through all of this conversation, this is a force moving the speed of light. Okay? It doesn't do this mixing thing. It's like gravity. Gravity forces do not mix. That's the only reason why you have the, what's that word I have to keep remembering? You know, that they've turned into some other kind of thing. Superposition rule. The superposition rule for gravity is that the force from one gravitational body or one charge doesn't mix with the force from another charge to create some kind of new charge. They add. So whatever you can add forces, but you can't cancel any force. You can never cancel a force. You can only add to it. All right, and that's how gravity works. The gravity has to go from one object to the other object. It has to affect the other material object. It has to travel like light from the sun. Gravity from the sun has to travel to the earth and affect the earth. The earth's gravity can't blend with the sun's gravity, and the two forces interact. Forces don't interact. That's a rule. Okay, Newton should have said it. Forces don't interact with forces. It just doesn't happen. They have to use the conduit of a material, a piece of matter. The force can't mean anything till it hits matter.
And it would show that there was this interference calculation. There would not be a double frequency. And
well, I'm going to prove you wrong. And that's so... You're making a mistake, buddy. You probably should have sent me this video privately, and then I could have informed you that, no, don't do it, Holiday. You're going to be wrong again.
I suspect in that eventuality, DraftScience would have the out of saying, but that's because you're using a frequency counter. You're not directly measuring the voltage.
So again, it's just this fucking insulting crap. You know, I'm going to set this up so you can't make a complaint, first off, because now I've set it up where if you complain that somehow it was rigged, that means you did that right from the beginning and you knew you were wrong and you better. I mean, this is just such a bullshit tactic. All right, I should just imply that after this video you're going to go out and molest some kids, right? Because you're a child molester and that's what child molesters do. I mean, to not be able to realize how fucking insulting that is, you fucking cunt. I mean, I sit here for 7 years taking all this grief from all these fucking cunt trolls. All right, so some asshole like you can sit there and make some gratuitous comment like somehow you have some reason to believe I'm going to cheat somewhere. When I'm not the one cheating. I'm not the one showing people idiotic experiments. I'm not like Pirro, who points to fake experiments as evidence. I mean, fuck you.
And there we go into the problem where I say is you can't directly measure the voltage of photons. That's part of the problem.
Says you. So again, you're wrong again. You can, obviously, in my opinion, you're just provably wrong because I've seen it. Okay, I saw the guy just hold the wire an inch from the ground and a spark shoots through the ground and you hear the radio station. No radio, no tuner, no nothing. You hear it because the sparks are doing exactly what the electricity is doing, and the electricity is carrying a Morse code of sound, and it's just vibrating the atmosphere at exactly the same frequency as the radio station is transmitting.
You have to use its frequency characteristics to cause electrical resonance, and in that amplification, feed that amplification into a transistor amplifier to a speaker.
No, you don't. You don't have to use a speaker. You just, again, you can just amplify it and use an ammeter. So I'm not opposed to even amplifying it, but you can amplify the entire voltage. Okay, amplify everything. And the point is you'll know what the noise level is because you just leave the transmitters off and then you turn the transmitters on and you'll see the needle go up and you'll say, okay, that's what the new signal's doing. It's doing this to the needle. There. I now have a ground, I have a common, and I have something to compare it to. And that's all you need.
And I think that would be rejected as an experiment by DraftScience. I've conversed with...
Yeah, fuck you. Just fuck you. I mean, just with this petty shit. You know, I sit here and make these direct assertions. This is how it's going to happen, okay? I'm putting the experiment right out there and saying, yes, let's do this experiment. And that's not good enough for you. I'm putting my theory on the line with a really simple experiment that none of you lazy asses ever thought of or did. So physics for 300 years left all these questions unanswered and they couldn't figure out how to do this easy frickin' experiment. It's so fucking simple. And then you give me this horse shit? Yeah, you're such a cunt.
Steve earlier, and he likes the idea, and I think the idea, and I got the idea when I was thinking about a microwave oven, how it has cold spots.
So this is, Steve, don't take Hotliday too seriously. Yes, he's a nice guy. He's also one of you GBers. But don't take what Hotliday says too seriously because he's 60-40. And I mean 60 wrong, 40 right. So don't he's a nice enough guy, nice enough bloke, worth a listen. But don't take what he says too seriously, Steve, because he's a dumbass too often. And he's been a dumbass 3 times in a single fucking video.
Now, the general explanation for those cold spots are interference.
Yeah, well, whatever. I did get more nonsense, so I don't know if I need to go. I won't draw that yet. But it has there's interference has nothing to do with the cold spots in microwave ovens. The cold spots are in microwave ovens are because they're shooting photons and they have to bounce inside of a box and they have to get everywhere. And it's hard to do that. It's hard to get them to go everywhere.
But DraftScience could say, no, that's just bad reflections.
Yeah, especially a square box. I mean, understand it's a square box, okay? They could probably do, I don't know, what the microwaves might work a lot better if they had a spherical chamber, but that'd be more expensive to make. But yeah, obviously the corners are really bad places. You're not going to be able to get a bunch of light to go into those corners.
And particles just missing that spot. And that would be a reasonable counter-argument at first level. So I propose that the best falsification, and I don't, falsification here is not meant in a derogatory sense.
Yeah, it's always meant in a derogatory sense. It's a bullshit word anyway. What does falsification even fucking mean? It's such a bullshit term. It's like saying, it's that stupid elastic, inelastic thing. It just doesn't make any sense, and people should self-falsify or something. None of this crap makes any sense. You either find supporting evidence or unsupporting evidence. Evidence against. There's evidence for. There's evidence against. All this falsification crap is just bullshit rhetoric. Shove that shit.
Pejorative, for instance, science says this is a necessary feature of a theory. Is that it?
No, science doesn't say anything. So let's quit lying, okay? The church says. Okay, the fundamentalist wackos say. There's no such thing as science saying so. There's nowhere in the truth theory or in a theory of rationality that you would use an idiotic word like falsification. You'd say you either you support the theory with evidence or you have evidence against the theory. You don't worry about this word falsification.
It is falsifiable. When it makes a prediction, you can go and check that prediction, and if it ain't so, then you've just ruled out that theory. If it is so.
Right. Well, clearly the only thing I'm going to prove is that jamming, the simple answer, is viable. Jamming is a perfectly reasonable explanation for why there's a pattern. And that's what the experiment's going to prove decisively. That you don't need to think photons interact with each other or hit each other or blend into each other or have sex or do any of this bullshit or create multiverses. No, you don't have to believe any of that crap, and you can just believe that, oh, the frequency changes because see, the fucking antenna is a dumbass, and the fucking antenna doesn't know that, oh, you hit me with energy from over here, and oh, you hit me from energy over here. Yeah, the fucking antenna doesn't know the difference.
The standard philosophical doctrine is that, well, you've not shown it's wrong. You're not saying it's right, but you're saying, your model is working so far. So back to the microwave. I believe it's possible to put a test tube of water in the vicinity of two horn antennas of a powerful microwave source, and you'll be able to move it and make that water boil, and then take it out, and the water will stop boiling.
All right. So, just a huge mistake again. See, what he's doing is this is what everybody does. They're so used to seeing this shit in these lame-ass bullshit drawings that, they don't realize that the drawings aren't reality. That they're, they lack complete dimensionality. They lack the moving parts. They're just bullshit often. Okay, so he's forgotten something kind of obvious, all right, that when you have the microwave dish here, okay, and I can draw these little lines, all right, these lines aren't staying here and staying here and staying here and staying here. These lines are moving. Each one of the lines goes to every single one of these locations. This line goes to every one of these locations, and this line goes to every one of these locations. So the whole thing gets full of microwave photons. So if you put your water here, there's no way to get it in between, okay, the hot and the cold, the place where there are photons and the place where there are no photons. Now, when it comes to, again, so if you do a tuned signal, though, then you can pick up the difference because then phase matters, okay? And so obviously I'm arguing that I would agree with Hathliday in the sense that there's a 3 centimeter difference here between traveling. So there is a gap, but the gap can only mean something when the wave is standing. Okay, when the wave doesn't move. That means it has to reflect off of another surface and go back and forth and back and forth. So you have to create a standing wave to do the, let's put some water in this dead spot. Let's put some water in this dead spot. Let's put some water in this dead spot. So Hathliday is essentially validating my theory by pointing out that, oh, well, in between the peaks is nothing. There's nothing here, no photons. So there's photons, and then there's photons, and there's no photons between them. No photon there. No P. Yeah. P-H-O-T-O-N. Okay, no photon. And that's how this isn't a wave, okay? It's a bunch of photons coming off the antenna. Billion photons right here. Right here, right? And then nothing for 3 centimeters. And then a billion photons again. And then that one moves away 3 centimeters, and then a billion photons again, and then nothing, and then a billion photons again. That's what the radar dish is producing. a billion photons, then nothing for 3 centimeters. A billion photons, and then nothing for 3 centimeters. That's the reality. So, well, interesting hand jive there, have to concede. Very, very good. Cool. I like it. This world is just too far gone.
You put it in and it boiled. Now, talking about thought experiments, what does DraftScience theory predict here? I think DraftScience theory predicts here that the water will boil and then it will boil doubly quickly. So, yeah, it will never.
No, I don't predict that. I understand that all the energy is moving, and the energy will move right through every location, and every location will receive the energy over time, the same amount of energy over time. You can't undo that because they're moving waves. They're not standing waves. Sorry for the spittle, but it must be done. I'm just cleaning up. I know I probably should do that while he's talking, but I forgot.
Not boil, and I believe you can find a place for a centimeter wide test tube to essentially not boil.
Again, I would say it may be no, it's not possible really. I have to think about it, but I really don't. It's a moving wave, and you really can't stop it from moving. I mean, it's not a medium. In mediums, you can do this standing wave thing, but there's no medium here, so you're fucked.
Because the signal will be so attenuated.
You can't attenuate it. Again, you have to understand, it's just radiation hitting it. So always think about it like it was light bulbs, right? And you can kind of understand that if the light bulb's shooting light, it doesn't matter whether it's blinking, let's say, blink, blink, blink. So there's like 3 feet between the blinks of light. The light isn't not going to hit you. It's eventually going to hit you. Okay, so whether there's a gap or not, you can't step into the gap because the gap's moving. So, and there's no way to make it a standing wave. It's a moving wave. It just won't stand still. Because it won't stand still for the very reason that you can't destructively destroy the stuff in the middle. You can only add more light. So there's light coming. If you try to make it a standing wave by reflecting at it, the light it's not a force. There's no tension. It's not a medium. So all you'll end up doing is creating more light in more locations. You'll get hit with more energy. Put 2 light bulbs, you get hit by more energy. You're screwed. You can't stop it from happening. It's a force. You're really not getting this. And I don't know how, like I said, over all this time, you still don't believe light is a force. It's not crap in some dopey medium. It's a thing, a real thing, moving the speed of light. It's moving. You can't stop it. You can only absorb it. There's no other way to interact with it except absorb it with matter. There's no other cloth that picks up this water but matter. Okay, if you thought about it as like water, you can't stop it with anything other than matter. Nothing else will stop it. There's no force that'll stop light.
So that's my thought experiment on all this. I don't think it's terribly technically difficult. You don't want it in a microwave oven because
you don't want it in a microwave oven because it won't work at all, because then you have even more moving waves. And again, the waves will not destroy each other. That won't happen. They'll just add to each other. Somehow this just doesn't want to be. Half of it's my fault. I just got to keep remembering, never touch anything else but the space bar.
Microwave oven is designed to be reflecting these signals and not give much region for these interference dark spots. What you really want to do is surround it by water tanks, which will not reflect the energy back at the test tube, but absorb. Water tanks will absorb almost, to my thinking, most of the surplus energy.
So again, this, he's just made a he made a little mistake. Any one of us could do it, and and so he's just expounding on it by talking about all this stuff that really is irrelevant because he made the fundamental mistake of thinking radar is a standing wave, but it's not.
Yeah, so I got a little note here: RF versus gigahertz. So when it dawned on me, because for the longest while I didn't understand graphs.
It's like he's doing some kind of mind reader thing. I was trying to cue into DraftScience's brain, but yeah, it's way far advanced. I couldn't hear anything because it's like such a hugely pure and brilliant language, and all I can do is bark like a dog.
Science's theory of interference that he was predicting a doubling of the frequency, which the circuit was not tuned for. Ergo, it appears to go silent, but when in fact there is double the energy still there.
Right. So if they just tuned it to twice the frequency, then they would have exactly the opposite on-off pattern. At twice the frequency, the dead spots are active, and the active spots are dead.
To me, what very recently where that penny dropped, and probably from a video we made where it became just that bit clearer. So, but I was looking, okay, he wants direct voltage, and can I do it with this, with just an RC circuit with separate to an amplifier, a transistor amplifier stage, possibly, but gigafrequencies, oscilloscopes.
Again, what do you need an oscilloscope for? Okay, again, all you need to do is detect it. You don't need a pretty picture of it. All right, so all you need is a voltmeter and maybe an amplifier. Okay, but it wouldn't be a band limited amplifier. It would just amplify the electrical signal, all of the electrical signal, all of it. So it has to be capable of amplifying very high frequencies, obviously, but it doesn't have to do anything else. It just has to amplify the electricity.
To be hugely dear, yeah, excess of £10,000, dollars, just enormous prices for microwave gear. Also,
yeah, well, look, the point is I have the only ones I can afford. I have a multimeter that they give away free at the store. Okay, that's how bad it is. They give it to you for free. All right, when you buy something, they give it to you for free because it's such a piece of shit. And I took that, all right, and put it on the best AC signal sensor. I think it might have been DC. For the smallest volts, and moved it around the door of my microwave, and I got a signal. So that piece of crap was able to detect something, and I just used a probe. I didn't put a wire on it. I didn't enhance it in any way. I just took the frickin' cheap probe on the cheap multimeter, and I could detect the microwave energy.
Telescopes. Now, so therefore, the only practical way to do it with an oscilloscope and show falsification.
So again, the only way to do it. See these emphatic statements. The only way to do it. No, it's not the only way to do it. No, it isn't. Trust me. Oh, that's right. You can't do any of that kind of stuff. Damn. Trust science, because guess what? All the other scientists know there's got to be another way. Most people, when somebody says there's only one way to get on the roof, there's only one way to fix that flat tire, there's only one way, they all go, no, that can't be right. There's got to be lots of ways I can do it. I could have an elephant lift the car up. I could, maybe a rhinoceros stick his horn in it, and I can do it lots of ways. Fuck.
Or attempt to falsify by this false experiment, by either confirming the theoretical prediction or denying it, is a cheaper megahertz oscilloscope and doing it, and it will probably be better.
Again, you don't have to even use megahertz. 20,000 hertz would probably be enough. So you could do something on a pretty low. You don't need a hugely fancy frequency. Just you need enough watts. That's all you need. All you need is wattage. But obviously, if you use low megahertz, you got to need great distances to get interference patterns. But for my experiment, the two antennas in between, with the receiver in between, you can do it with any frequency. It's not frequency dependent, except for obviously you have to be further than the wavelength. So the wavelength can't be longer than the distance between the two antennas. So as long as the two antennas are at least two wavelengths apart, the two transmitters, you can do the experiment.
In a sense, be better to do it this way than with microwaves. You know, with basic radio frequency transmission.
Right, I know, but if you do it with basic radio transmission, then you have to have, instead of 100 watts, you're probably going to need 1,000 watts because you got to be 50 feet away. So you're not getting it, okay? The lower the frequency, the bigger distances you got to do the experiment over. So you have to do it outdoors.
Easier, safer, but the question remains: is how does DraftScience suggest we detect these radio frequencies? Because I believe we.
Okay, to be clear, what I suggest is no amplification, no receiver when you do the two horns next to each other experiment. Just use just detect the voltage, and when the two horns are opposite each other, you use a receiver and receive the signals, the frequencies. But you don't need to tune to them specifically. You just need a device that can detect all of the frequencies.
Necessarily have to have a tuned circuit. That's the only way. You can't, there's so much light and noise hitting these things anyway. With photons, you can't measure directly.
So of course you can. The whole point is say this room is kind of bright. Well, I could put a new light source in the room that's of a specific nature, like a blue light, and that'll be easy to detect from anywhere in the room, even though there's lots of noise, because that signal of blue will be way above the blue noise, right? And even if I did a white light, okay, that was exactly the same as all this light, same mixture of colors, all the colors, and I just added some more white light, the fact is I could measure it on a meter, that the room is now brighter. I could put a light meter in here, and I could take my camera has a light meter in it, and I could detect, hey, there's more light in the room, because now I'm above the noise.
Light hitting copper bars, just can't. Whatever colour.
Yes, you can. Okay, I've seen it. Okay, don't trust me. I don't care. Go out and search the videos. Search for radio without radio or something. Something like that. Music without a radio. Something like that.
Light, or not colour of light, the invisible light, infrared, ultraviolet, radio. Yeah, there's no way to do it.
Yeah, there is, and especially with light. Like I said, it's really easy with light. Light meters work really well at detecting more light in the room. So, bullshit.
So that's a problem for DraftScience's thought experiment, or new thought experiment about the two-directional.
It's not a problem at all. Blah blah blah. Says you'll be wrong.
System.
You'll be wrong again. Wait, been wrong 4 times in this one video.
So even regarding my thought experiment about the test tube, I imagine because this isn't the mode of philosophical working.
I didn't play this part yet, so I don't know what he's saying here, right? Because it's just there's a point where he just says so many bullshit things, and I just say, fuck it, I'll just make a video. So I haven't heard any of this yet.
Of DraftScience is that rather than staking his reputation on the line and saying that this is how this construct this, I guarantee you this is going to happen. If it doesn't, we can throw my theory away.
Like I said, I don't think you can throw the whole theory away because it still explains magnetism better than any theory around. It's just like if they find that photons are actually bent by gravity, it just means, well, I gotta come up with a rational reason why. Because I'm not going to say bent space did it. So it's not catastrophic. But clearly, if the experiment shows photons are interacting with each other, I'm going to rationally say, boy, that sure as fuck doesn't make sense. Yeah, my theory doesn't explain why a force is interacting with a force, because guess what? Forces aren't supposed to do that.
Yeah, that's what I want. That's what I say is required for a falsifiable theory. And I'd say DraftScience is very close to it at the minute.
Yeah, that's right. I've got an experiment that's going to wipe out a whole big part of their propaganda. So all the radio experiments are going to be thrown in the garbage now, okay? Because they're really not proof of anything. It's the simple answer is jamming, the complex answer is interference. So clearly the rational physicists are going to have to concede, yeah, the simple thing did it. Okay, okay. There's no Sasquatch. It's a mountain goat behind the tree. Okay, I thought it was Sasquatch, but yeah, just a mountain goat. Okay.
And I, Steve, or DraftScience, in conjunction or separately, could go about making a proper test if he can clarify exactly how he expects to be able to make the measurements he thinks. Because I think a rather practical and physical way is this test tube business, right? But
yeah, well, I know, but see, you're wrong because you didn't think about this. They're not standing waves.
it could be argued, if I was to think from DraftScience point of view, is that if it demonstrated what I say it would demonstrate, not boiling, is argument could be found afterwards, and this is the backward working of backward explanation to make it fit that DraftScience suffers from.
So again, he just keeps doing this thing like somehow I've connived something or contrived something. No, that's what all of you people keep doing. You keep contriving experiments. You keep just showing one particular way to do the experiment. You're the ones who are fixing the evidence. Not me. You.
If I was to be DraftScience and say, I'd say, clearly water is resonating, and water is tuned to that frequency, and the reason it's disappearing is because double frequency doesn't resonate that water.
Yeah, well, I'm not going to say that because I obviously think the double frequency is probably going to make the water boil even faster. So I don't think the water cares really. You know, once it gets to a certain level of frequency, it just considers it all kind of infrared radiation, and it's just going to get hot. So I think the more, if you go from 10 gigahertz microwaves and you double it to 20 gigahertz microwaves, guess what? I think water boils even faster, but nobody wants to live in a house where 20 gigahertz is fucking radiating them.
Correctly. See?
But it might be true. Like I said, I don't know enough about the chemistry of water. I mean, water molecules might only vibrate at certain resonant frequencies between, say, 6 gigahertz and 15 gigahertz. Maybe there is some limit. But it does seem obvious that water absorbs radiation really well. So it seems likely you can heat water with heat. You know what I mean? So clearly it absorbs radiation fairly actively.
And again, DraftScience would be able to champion and say, no, Eiffel-Day's experiment is faulty.
So again, he just keeps implying that somehow I haven't put it on the table. I have put it directly on the fucking table. I'm making arguments on message boards. I'm putting it right on the fucking table. And you weaklings, you cowards are the ones who have been cowards for 7 fucking years.
Just the same way you can say, Steve's experiment is faulty because he's using a frequency counter. Frequency counter is injecting DC amplification, positive, negative rails.
Yeah, bullshit. So there's no indication that I've said Steve's counter doesn't know how to count a frequency. Now, Steve has pointed out it's a little bit sensitive to how the waveform is. So certain waveforms it doesn't like too much. But that's all there's been. I haven't made any critique, you fucking cunt. I mean, how can you be so fucking ass-burgered that you can't understand how you're implying something about my character, you stupid fat fuck?
Blah, 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 etc. I think that's about it. All right, so last point. In DraftScience's criticism of the standard two-horn interference experiment, the standard one by Walter Lewin, wherein a sound signal is placed on top, it is modulating the carrier wave. Well, that's the first part of the experiment, and then we look to the results. Now, so far, DraftScience has criticised the results side of it.
Bullshit! So again, no, bullshit. I haven't criticized any fucking effect ever. Okay? I'm criticizing ludicrous, phantasmagorical, religiously crazy, fucking idiotic theories of how fucking physics work. Their theories are baby talk, for fuck's sake. This is shit a fucking 7-year-old comes up with. Oh, a new universe is created. It's gumdrops and candy canes. It's fucking baby talk as an explanation. You fucking idiot. And you're falling for that shit? Black energy, blah, 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 blah. You fall for that shit? You fucking cunt.
Taken that is not explaining the front side, in fact explaining how radio works. How is it in a particle theory like his that you can put a sound signal to attenuate photons, in his case photon pairs? What does it mean in a particle theory to be able to modulate?
Because guess what? The fucking carrier frequency is, I said 1 million times. No, it's actually 1 billion times. It's going up and down 1 billion times. Okay, from from like photon to no photon, photon to no photons. It's doing that 1 billion times more often than the audio signal. 1 fucking billion times more. So you can't really, you're too stupid to fucking understand that the carrier signal is on 1 trillion photons. It's so much slower. Dumb fuck. It's like saying, this is as dumb as somebody saying, well, how can you hit that Morse code key and make electricity that is dotting through the wire? You know, not hard at all, dumbass.
The light output, as in radio frequencies are, their signal can be AM amplitude modulated or FM frequency modulated.
Well, we know that all of these conversations,
that we put the information of the sound atop into.
We know that all these experiments are done AM, so we know it's all just a simple audio signal on top of a frequency that is 1 billion times fucking finer in resolution. 1 billion times smaller pixels.
These invisible light rays. DraftScience kind of implicitly, by just speaking about the results side, I take it, is accept.
So again, this horseshit, just talking about the results side. Where am I talking about the results side? I'm talking about their causes being ludicrously stupid, unsupported by any evidence whatsoever, and completely contradictory. One time the theory says a single photon splits into a wave function and the wave functions interact and it turns back into a photon. The next day the theory is, no, individual photons fly through empty space and somehow bang into each other and decide to go somewhere else. Their theory has no continuity. It's absolute babbly shit. And you as some dumb fucker can't hear me saying that clearly? I'm saying their cause is ludicrous crap. I'm saying, yes, there's a pattern. I'm not in any way denying the fucking effects of the experiments, you lying sack of fact shit.
I think, and he talks in a manner of acceptance about the possibility of this amplitude modulation. How is amplitude modulation even a possibility in a non-wave theory? How is
how is it possible to send Morse code when the electrons are moving much faster and the force in between them is obviously moving the speed of light? How does almost the speed of light? How does an almost the speed of light thing get turned on and off at 1 billion times a slower speed? How can you possibly do that? That's insane. No, that's perfectly reasonable. You dumb shit. See, this argument might make some sense. Like, say if he was saying the paper had giant pixels like this, okay? The paper was just made of 6 pieces of pixel. And then you said, well, how can you draw anything with 6 pixels? You can't do that. But no, if you have 1 billion pixels, then you can draw all kinds of stuff in it. He doesn't understand resolution. He doesn't understand anything about this fucking argument. He just makes these ragged fucking ad hominem implications. This stupid fucking dumb cunt. This ass for brain burgered.
Amplitude modulation possible in a particle theory of light? I think that's a very interesting and poignant question.
Yeah, it's poignant at asking, again, how does electricity that's moving almost the speed of light get turned on and off by a Morse code key? How does that happen? And then on the other end, the key goes up and down and makes a noise, just like it was a radio signal. Yeah, just like that. Fuck.
And problem for any particle answer.
Fuck you.
As poignant and significant as...
Dumb shit. Can't even figure out what a standing wave is. Dumb ass. You pompous douche.
The drag question to a particle theory.
Yeah, I've already done the drag. See, they always got to change the motherfucking subject. You don't even know what is velocity. You don't know what inertia is. You have no fucking theory at all. None. And yet you're picking at somebody else's theory when you have zero theory of why things move. You fucking vacant-brained pieces of shit. Oh, it's bent geometry. That makes things move. The bending of the non-existent nothingness. Fuck you. Picking at anybody else. Fuck you.
Gravity is to, I forget the guy, in Mendham's gravity, let's call it then for now. So, there we have it. Hope the volume's up here. We'll go and test it.
Well, at least it was titled right, okay? It was a shit video. Poor quality. Yeah, it was a really poor quality reply. You said a lot of dumb, stupid shit. Really fucking dumb stuff. So good. You humiliated yourself again. Bravo, dumbass. You know, I try to like you, but again, you just keep doing this shit. Like you have some right to imply that I have cheated anywhere in these arguments. You fucking cunt. When you see the antics these other assholes pull, you see what they're doing at this fucking message board. They can't stay on the subject to save their fucking lives. And here you are insulting my integrity, you fucking ass? Fuck you. Fuck you. Okay. That was fun. So, on to the next fuckhole. Lying fucking cowards.